Let's be honest, you often leave your revision to the last minute, and that's exactly why I created this video series. Every day for 14 days, I'm going to be going over a question from the Edexcel 2023 Paper 1. Plus, for every single question, I've created a never-seen-before bonus part that really helps you push your grades up. Today's one especially involves a lot of problem solving, so if you're looking for an A star, this is the kind of question you need to be revising. Let's get into it. So this question says you've got a continuous curve that has equation y equals f of x, and it gives you a table of values for x and y with some missing. So again, a lot of the time, especially in the most recent papers, they're telling you what needs to be used. So it says the trapezium rule was used to get an approximate area between 3 and 4, and the area that came out from that approximation was 17.59. And with all of that information, you need to then show that this. So we know we're going to be using the trapezium rule. This is given to you in the formula book. So you know that area is going to be the h over 2, so that's the height of the trapezium over 2. And then you take your first value and your last value, so y0 plus, and then yn, the last value that you have, plus 2. And then we're going to have y1 plus y2 all the way up to all the other values that we have. Now, the bit that most people get wrong, and this is a really easy mistake to make, is to figuring out what this h means. There is a little formula for what you need to do to calculate h. And a lot of people will do 4 minus 3 here and divide by 6. So have a look at that and think, why is that wrong? They count this 1, 2, 3, 4, 5, 6, and they think we divide by 6 to get the width of each trapezium. But what I would recommend instead is you just think about this as a trapezium. So you've got this trapezium here, and the height is always this bit. So it's the gap between the x values that you're using. It's really easy to see here that the gap between these two is just 0.2. If you only have the first and the last value, and you know you need 5 strips, then you would divide by 5. So 4 minus 3 is 1, divide by 5 is 0.2. But you don't need to do it. You can see this here clearly, that the gap between them is 0.2. So straight away, you can fill that in. So we've got 17.59, then we've got 0.2 divided by 2, first y value, which is a, our last y value, which is 13.5, plus 2, and then we fill in all the other values. Okay, I'm going to simplify it a little bit, so that we've now got this expression here. So I've just expanded out that 2 and divided this by 2. And then I'm going to divide here by 0.1. Rather than timesing all of these by 0.1, I'm going to divide by 0.1. That's 175.9 equals, and then we can simplify this. Now we can see we've got already a plus 2b. So I've taken that a, I've got the plus 2b, and then I can just add together all the other values. And that comes out 124.9. So we've got that. So we've almost got what we need, but we just want a plus 2b to be together on one side. And then we just need to minus 124.9, and we get what we wanted, which is 51 equals a plus 2b. Now, let's have a look at part B. An important point that I really, really want to dwell on here is that you should not leave out part B if you couldn't do part A. Part A is a show that question, so it's giving you the answer. So if you need that in the final part, you've already got it. The amount of students I see lose marks because they don't try the part B question is crazy. So I don't want that to happen to you. So always try all parts of the question, no matter how you did earlier in the question. You never know the marks that you're going to get. Okay, let's start with part B. So it says, given also that the sum of the y values in the table is 97.2, find the value of A and B. So you should be reading this and thinking, now, I can make an equation from that quite easily. I just write these as a sum, and I put it equal to 97.2. So that's what I'm going to do here. Okay, and then I'm going to simplify. And I'm going to make A the subject here. So A should be equal to 28 minus B. The reason I've made this the subject is because I want to substitute it back into this equation. We have got simultaneous equations here. We've got an equation here in A and B, and we've got an equation here in A and B. So I'm going to take my other equation, I'm going to do it over here, 51 equals A plus 2B, and I'm going to substitute in for A 28 minus B. So we've got 28 minus B plus 2B. That's 51 equals 28 plus B. And so B is equal to 23. Now we've got one of our values. We just go over to the other one over here. A equals 28 minus 23. We've got 5. And so we're going to write our conclusion that A equals 5, B equals 23. Always make it nice and easy for the examiner to give you the marks. Okay, so you're probably thinking, right, where is this bonus question? I'm going to show it to you now. So this bonus question says, by considering the trend in the y values, determine the concavity of the curve y equals f of x, hence state with a reason whether the approximation of 17.59 is an overestimate or an underestimate for the true area. This is a difficult question. It's really getting you to think about what is happening with this function. I am going to leave you to try this now. So have a go, pause the video and try it for yourself. And then the answer will come up in about 3 seconds. Okay, so here's the workings that I've done so far. So what I've done is I have taken the gradients between each of these points. I've labeled them A, B, C, D, E, and F. And I found the gradients using y minus y over x minus x to be these gradients here. Now, the reason I've done that is because concavity is about whether the graph looks like this or looks like this. And that makes a huge difference to whether the trapezium rule is an overestimate or an underestimate. So I'm going to show you. So we start off with a very high gradient, like 59, so something very steep. Then it gets less steep at 31. Then it becomes negative. So it looks like here it's concave, concave, and then here it kind of turns the other way a little bit again because it gets less steep and then it gets more steep again. So for most of this function, it's concave. And the reason that's important is if you imagine you've got concave and then you've got a trapezium underneath, because the trapezium rule is just using the area of the trapeziums added together. If we look at this, if we had a trapezium, we're going to have a gap. So this would be an underestimate. So here we would say it's likely an underestimate because the function is concave for a majority of the values. So that was quite difficult. You had to identify that you needed to look at the gradients to determine whether it was concave or convex, and even then it wasn't very clear cut. If it was a question like this where it wasn't always decreasing the gradient so that it would be concave, then they would probably accept a different answer. They would probably accept you can't tell. Because at some points it's concave, some points it's convex, or you could say something like this where it is an underestimate because it's concave for the majority of the value. So let me know in the comments, did you give this a go? Did you do it like me? Did you do something else? I'd love to hear it. Tomorrow we're doing question 6 from the paper and it's a logs question, which can sometimes be tricky, and I'm adding again another harder bonus question. So it is already ready. It'll be around here somewhere. Otherwise, hit the subscribe button so you don't miss the video tomorrow. I'll see you there.